All right, let's do some graphing. So let's graph this exponential function, 3 raised to the x minus 2, so all of that's in the exponent, plus 4. All right, so I feel like difficulty level jumped up, but let's think about it. We already know what 3 to the x looks like from the previous page. Well, this looks exactly like 3 to the x, except it's shifted, all right, 2 units to the right, also 4 units up. So we can do that using transformation. So this graph looks like 3 to the x but shifted 2 units right. And 4 units up. All right, so the thing we can do is let's think about 3 to the x and then just do transformations to figure out the rest. So if you go back to the first page, we already know some things about 3 to the x. We know that it has the point 0, 1 on it, so let's look at 0, 1. And we're going to transform it. All right, so 0, 1 on 3 to the x will turn into what on this new function? So let's see. 0, so we're changing the x value by shifting it to the right. So that means we're going to add 2. So our new x value would be 2. And for the y value, we're shifting 4 units up. So we need to do 1 plus 4. And so we get the point 2, 5. All right, so that's going to be on our new graph, 2, 5. All right, so we got 1 point. All right, so then we just need to choose another one. So we're going to choose another point on 3 to the x. Right, so we know 3 to the 1 equals 3, so we could use the point x equals 1, y equals 3, and we're going to transform it so that it works with this graph. All right, so again, x value, we need to add 2 to it, and for the y value, we need to add 4. Okay, so now we have the point 3 and 7. All right, so there's one more major characteristic that we need to be able to graph this exponential function. It's the asymptote. So we have an asymptote at y equals 0. All right, so on 3 to the x, the asymptote is y equals 0. But on our function, remember we're adding 4 to everything. Our asymptote is going to be at y equals 4. So 1, 2, 3, 4. So that means our graph will not cross this line. All right, so it's going to get closer and closer to our line up here, and it's going to go up that way. Okay. All right, so this is the graph of this exponential function, 3 raised to the x minus 2 plus 4. So it looks just like before, but it's shifted 2 units to the right, also shifted 4 units up. All right, now let's talk about domain and range. So let's look at the domain and range of the previous page before we move on. All right, so looking at this graph right here, 3 to the x, so this is on page 1. Could you tell me the domain of this function? Well, we could do any x value, right? We can plug in any x value. So it's from negative infinity to positive infinity. What about the range of this function? So what y values are possible here? Okay, 0 to infinity. Are we going to include 0 or not? We're not, because we have that asymptote here and our function is not going to cross it. What about the function that's decaying, so the one that's getting smaller? What's the domain of this function? Well, it's going on this way, negative infinity to positive infinity. And the range? Well, there's nothing down here, so it's going to go from 0 to infinity. So it's going to be the same. All right, so this is the domain and range of any exponential function that hasn't been shifted. So now let's go to the problem we're trying to work, where we have to determine the domain and range of this one, 5 to the x minus 3 plus 4. Well, can we figure out the base function? Well, it was 5 to the x, right? So the original function would have been 5 to the x. But then it's been transformed to 5 to the x minus 3 plus 4. So what does that mean? Shift it to the right 3 units, shift it up 4 units. Okay. All right, so let's go back to the original, talk about domain and range. Well, we already discovered the domain and range for every exponential function. Domain is always negative infinity to positive infinity. We can plug in whatever number we want. Range is always from 0 to infinity, not including 0. So these are the possible answers we could get from our functions. These are possible y values. Okay, so now let's look at our new transformed function. So the domain of this, well, we need to shift 3 units to the right, but if we're going from negative infinity to positive infinity, shifting 3 units won't do anything really. So it's still from negative infinity to positive infinity. Well, let's talk about the range. All right, so it was 0 to infinity, but what are we doing with y values here? We're adding 4 to it, so the range is going to be 0 plus 4 to infinity. So the domain is from negative infinity to positive infinity, and the range is from 4 to infinity. All right. Now let's talk about the exponential function with base e. So e is very easy to think about e as a variable, but it's not. It's just like the number pi. So pi has a symbol, but it's really the number 3.14. Same thing with e. E has a symbol, but it's actually the number 2.71, blah, blah, blah. All right. So this is a nice exercise to think about. Where does the number e come from? Well, it actually comes from this expression. So where you take 1 plus 1 over n and raise it to the n power. So try plugging in different numbers for n and make them get bigger and bigger. All right, so if you take your calculator, maybe 1 plus, let's try 1 over 100. All right, and I'm going to raise that to the 100 power, 2.7. And so if I do even bigger numbers for n, I should get closer to 2.71. And let me show you where to find this in your calculator. All right, so it should be right above the ln button, e to the x. So to figure out e, you can just do e to the 1, and you'll get that number, 2.718. All right, and so we'll talk about this on the graph in the next video.